Hi guys, my name is Ashley Colchado, and today I'll be talking about my physics lab 4 on oscillations. So, some purposes of the lab: I use tracker to examine the movement of a mass at the end of an oscillating spring, and so then I use this to create a computational model using GlowScript, and using that I compared the predicted motion and the observed motion. There was a lot of concepts in this lab, but the key concepts and the ones that I used the most were Newton's second law, where it states that change in momentum is proportional to the net force applied. Also, the energy principle, which states that the system's change in energy is the sum of work by the surroundings and thermal energy. Some initial conditions for the lab. I did use the pre-recorded video in Tracker, and that's what you see here on the right. And so here on the left are the initial conditions for this. So that would be the object's mass, which was 0.402 kg, the spring constant, which was 6.83, the velocity at 0 meters per second, the gravity which was 9.8 meters per second squared since we're on Earth. The position was 0 in the x direction, negative 839 in the y direction, and 0 in the z direction. Um, and this was in meters. And then the system was the mass, the spring, and Earth. And the relaxed length of the spring was 0.123. For my computational model, most of it is copy and pasted. I did obviously have to update some of these lines of code to find what I needed. I had to update the spring constant and the relaxed length of the spring to just match my video that I used, along with some of the other initial conditions like the position. But here on the right, I use the kinetic energy formula and the gravitational energy formula and also the spring energy formula um, to find these. And then I had to solve for K, and I kind of just rearranged some equations. Same thing for L0. In this part of the computational model, um, I had to find the force of gravity and then the force of the spring, which I did, as you can see in these bottom lines of code. And then in this part of the code, I mainly focused on the total kinetic energy, the total energy, gravitational energy, and then the total spring energy, which you could see in the formulas on the right. And I kind of just applied that to my code and edited it so that it could um, match what I needed it to. And these were my final computational model results. On the left here, you can see change in energy versus time. And then you can see in the middle the x position versus time. And then the y position versus time, which look very, very similar. And also the model and the experiment are very, very similar. A little more difference in the y position versus time, but yeah. So, does this satisfy the energy principle? Yes, it does. And this is because there's no external force changing the isolated system, and the change in energy should be zero. As you can see here on the right, this is the change in energy versus time result that I got. And when comparing the oscillation periods in the x direction, it was 1.709 seconds newtons per meter, and then the y direction was 1.519 seconds newtons per meter. So clearly the y direction is faster. Thank you.